Hi guys, I'm going to talk about Unit 4 designing studies. I'll attempt to get this done in about 10 minutes, and I need to because I need to go pick up my kids from school. I hope you all are having a good day, and just keep in mind that this video is not intended to teach you this like you've never known it before. It is taught to remind you things. I do talk fast. Pause, rewind, and make sure you pause and ask questions, like write down questions for me and bring them to class. All right, let's go. Couple things to remember sampling methods. I have two up here, a voluntary response and a convenience sample. I think I spelled convenience wrong. I did. That's embarrassing. I'll change that now. Make sure you remember that a voluntary response is like American Idol. It's where you call in, you text in to vote. I see these quite a bit on the Star Tribune. Vote for your favorite candidate, or on ESPN, who do you think should be the Heisman winner? Voluntary response samples are not good samples. Why? Because people who care about the subject are the ones who vote. People who are emotionally driven, they vote. People who don't care either way, they don't vote. And so we don't get a good indication of what the population really believes when only the emotional people vote. A convenience sample would be a sample where if you wanted to find out how many people are going to the U of M and you went to the lunchroom to ask people for your sample. The lunchroom's convenient. There's lots of kids there. A problem with that, though, is you're missing out on a big population. You're missing out on a population of people who go home for lunch or do post-secondary. A convenience sample might be the person at the mall who stops you to ask you for a survey. It's what's convenient for them. Again, both of these will produce results that are biased because they will not represent the population that it is intended to draw conclusions about. Okay, one thing when you're talking about bias, make sure you talk about which direction. What do I mean by that? For example, if I wanted to do a phone survey, I'm going to randomly call people's homes at 2 o'clock in the afternoon. I work for a cooking company and I want to see how many people a baking company. How many people use my pans? I work for Martha Stewart. How many use Martha Stewart's baking pans? On top of that, I ask, how many times a week do they bake? I get a statistic that says on average, people bake 3 times a week. This is going to be a biased result. Why? They called it 1 o'clock. It is probably, the direction it is going is probably a higher statistic than what we should have gotten. Why? Because lots of people who are at work may like to bake, but they don't have as much time to bake. If I call it 1 o'clock, I'm either calling stay-at-home moms, stay-at-home dads, or people who are retired. They have more time to bake, and as a result, the statistic I got would be higher than what it really should be. That's what I mean by direction. So when you're talking about bias, talk about why it's biased. We missed out the people who are at work and what direction the bias is. It's a higher statistic. Why? People who are at home, they're going to cook more or bake more. All right, a simple random sample. I'm going to talk about this in terms of Armstrong High School. At Armstrong High School, there's 2,000 kids. I want to sample 100 of them to find out what kind of pizza they like. I need a random sample. I put all 2,000 kids' names in a hat on the same size paper. I shake that hat up. I pull out 100 names. I ask them what kind of pizza they like. That's the hat method. Anytime you need to randomize, use that method. It's appropriate, it works, and it's easy to describe. A stratified random sample would be if I needed to make sure that it was a little more representative of the population. For example, if I wanted to ask everyone here how much pizza or what kind of pizza they liked, there is a chance I could get mostly seniors in that sample of 100 kids. So I change it to 4 hats. Now I have a hat for freshmen, a hat for sophomores, a hat for juniors, and a hat for seniors. What do? I get all their names on the same size sheet of paper. I shake the hat. I pull out 25 names from the freshmen. I do it again with the sophomores, again with the juniors, again with the seniors. What is the benefit of a stratified random sample? It is going to be a little more representative of the population. But it's not truly a simple random sample because I can't get all combinations of size 4 or size 100, whatever I choose. In a simple random sample, I could get 100 seniors. There's no chance of that in a stratified random sample. In order to be a simple random sample, I need all combinations of that sample size to happen. That won't happen in a stratified. What is a cluster sample? A cluster sample is I would use if I was running out of time. I don't want to write everyone's name on a hat, so I'm going to write all the advisors on a hat. Advisory teachers, there's like 40 of us. I'd put all the advisory teachers' names on a separate sheet of paper, equally sized, put their names in a hat, shake the hat up, pull out 10 names. Then what I'm going to do is I'm going to interview everyone from their advisory. So if my name was pulled out of a hat, my entire advisory would be sampled and they'd be asked if they like cheese pizza or what kind of pizza they like. Using a random number table. I'm going to come back and make a video over this, but make sure you understand how to do that. Experiments. A comparative randomized design. We talked about that in class today. Excuse me, I do have a little cold and my allergies are bugging me. A comparative randomized design is where we have a group of subjects or experimental units. We have one hat. They're all in this hat. Or I'm sorry. Yeah, they're all in this hat. 100 people in here, 100 subjects. Using the hat method, or an SRS, using the hat method, they go to group 1, group 2. They get their treatment 1, their treatment 2. We look at the response then, the outcome, okay? The treatments are our explanatory variables. What is a block design, and what is the reason for it? Let me go to a new page for that. There's a good reason for the block design, and the main reason for that is when I look at a comparative randomized design, I have my subjects. They go to their groups. They get their treatments randomly. Don't forget about randomly. That's really important. They get treatment 2. We look at the response. This X and this Y, okay? Now, if we're talking about a vitamin, let's say it's some sort of vitamin, we want to know that X really does cause Y. And remember, the only way for causation is a well-designed experiment that has randomization, control, and uses enough subjects. If we want to know that X causes Y, well, I need a well-designed experiment. But if I'm dealing with vitamins, and I look at the response, and treatment 1 does significantly better. Well, I may want to produce that one. I may want to market that one. But how do I know that there's not a lurking variable out there? That lurking variable could be that there was more women in the group. And women could respond differently to this vitamin. So what do I need to do? I need to block it. I need to have a block for boys and a block for girls. And they go through the treatment 1, treatment 2, and they randomly go to their groups. Treatment 1, treatment 2. And then I talk about the response for both blocks. How do I block? I block by the variable that's more important. For example, if I'm talking about dogs, do I want to block, and I'm talking about vitamins for dogs, does it make more sense for dogs to block by gender? Or does it make more sense to block by breed? Well, I say in this case, when it comes to a dog, that X causes Y. What is affecting this? What could be a stronger lurking variable? Is gender going to be a stronger lurking variable? Or is breed? In my opinion, from what I know about dogs, breed is going to have more of an effect on this response. So what am I going to do? I'm going to block by breed and have separate hats for each breed. All right, moving on. So we talked about block, we talked about why we should do it. I'm going to make sure I got everything else on that page. Oh, the matched pairs design is where subjects get both treatments. That's my boot example I talked about in class. Okay, let's move on here. Let's see. We talked about why we should use it, the placebo effect. Why do we use a placebo effect? Why do we use a placebo? That's for control. For example, if I have subjects, here's my subjects. One is treatment one, where they just are observed. Okay, wait and observe for sinus infection or ear infection, whatever. Treatment two, and they randomly go there, don't forget that. They get a pill. And after a week, or we could talk about it as, I don't know, let's talk about it for depression. Okay, depression, they get a pill, they get observed plus music. We look at the response, okay, and we know that the pill wins. Treatment two is better, significantly. Well, there's a lurking variable there, and that is, did the placebo effect happen? Meaning everyone, or oftentimes people feel better when they take medicine, okay? So what we need to do in order to control this placebo effect, we want to say, well, how do we know that it was actually the pill that made the depression better and not just the placebo effect, the sheer act of taking a pill? Well, how I do that is I need to give treatment one a placebo pill. And that's the reasoning there. Statistically significant means the results were so great, it wasn't just by chance. And then we confirm this with our significance tests we've learned. When we talk about confounding, we need to talk about the z variable, how it affects the y, and how it's also tied to x. For example, people who study more may get better grades. What else affects grades? Well, maybe, now I just used a bad example. People who study more get better grades. What else affects better grades? Well, work. Okay, I botched this example a little bit, but I think we can still go with it. We can still kind of get it back together. So we could do some kind of experiment about how often you study and your grades, okay? Well, what else would affect grades? Maybe if you work full-time or not. So you'd say, well, the bad grades, okay, the bad grades were not because the person didn't study that much, but because they worked full-time. It's something else influencing it. And now we don't know if the grades were because they worked full-time or because they didn't study. If we can't tell the difference between this x variable and this z variable, then these two variables here are called confounding. And again, I botched that example a little bit. I will post another video over confounding later to help us out. I'm sorry. It's all in my attempt to kind of finish this up and make it short enough for you so it's not a huge burden on you to watch these videos. The last thing I just want to remind you, the only way to establish causation is a well-designed experiment. In a well-designed experiment, what do we need? We need randomization, control, like a control group for comparison, or a placebo, something to control. We need to compare these guys, so we need some sort of control, or we need to control the lurking variables. For example, we need to make sure everyone takes the class at first hour, so they're all at the same time. Or if it's something about medicine, we need to make sure that they all eat the same types of food, controlling lurking variables. And then finally, we need to use enough subjects. And then if it's possible, we want a double-blind experiment. That's where the experimenter doesn't know what kind of pill they're giving the subject, and the subject doesn't know what kind of pill they're getting. This oftentimes can't happen only because the experimenter needs to know, well, it can happen in medicine. It can't happen, for example, if you were going to test out different types of skis, or you were going to test out different types of exercise classes. Well, then the subject knows what treatment they're getting. All right, I'm at 15 minutes, 5 over. I'm sorry, you guys. I hope this helped when it comes with just a quick review of some of the main concepts of Unit 4. Have a good one.